Thanks for joining us today. Today we'll have our guest speaker session. Today we have Karolis, a PhD student from University of Bath, a center in accountability, accountable, responsible, and transparent AI, supervised by Professor Simsek and Professor Bedford. His main research interest is in interpretability of reinforcement learning agents. He was one of the co-organizers of MineRL NeurIPS competitions. The floor is all yours, Karolis. You can get started.
Sure. Thank you, Rahul. Hey, everyone. I'm Karolis, and I'm going to talk about VPT, OpenAI's Minecraft agent. So let's jump right in. So let's pause it here. Now, the question is, what will VPT do if it sees a villager standing under a tree? The villager looks a bit like a tree, and we also trapped the villager so it doesn't run off, and there are no prizes for guessing what happens here. VPT, the agent, just goes and chops the villager. If it looks like a tree, it gets chopped like a tree, I guess, and it does take quite a lot of punches to take it down. And when it does so, it even checks the inventory for logs, and yeah, no logs there. So that's a bit of clickbait, to get you interested in this. And the outline of the talk will be, it will have two parts. The first will be the overview of the paper. It's the work that's already out there. And the second part will be the first public reveal of a slightly unfinished 3 blue 1 brown style deep dive and some current work. And yeah, I'm very happy to hear feedback on that second part. So let's go to the paper now. This is the paper in question, Interpretability in Action, Exploratory Analysis of VPT, a Minecraft agent. And it was accepted to the Mechanistic Interpretability Workshop last year at ICML. And me, I'm from University of Bath. Most of my co-authors are from Mila in Canada, and one of them, Steph, is at CMU. And the work stirred up a bit of interest on Twitter or X, probably because of the video of the villager getting chopped down, and even one of the main authors of the VPT paper, Jeff Clune, responded to that saying, "Sorry, villagers, a good reminder that training agents to emulate humans has dark downsides that need to be addressed before empowering agents in any situation of consequence." Also seems like very interesting work. Yeah, we were flattered by that. And my favorite response on Twitter was this one. Someone made this meme, VPT as the Terminator. Is this a tree? Finally, I ordered a t-shirt with this, but it hasn't arrived, sadly. I was hoping to wear it today, but oh well. Anyway, so what is VPT? It stands for Video Pre-Trained Transformer, I believe. It plays Minecraft. It was released by OpenAI back in the Stone Age of 2022, 3 years ago. And it costs somewhere between $1 and $10 million to make. And there are two main parts of it. The architecture is a ConvNet, convolutional neural network, and a transformer. And here, importantly, it only has 128-step memory. That's the context length. And that's 6.4 seconds in real time if you measure it in Minecraft time, which is 20 frames per second. And it was trained first on 70,000 hours of YouTube videos, but you're not allowed to say that. And then 230,000 hours of reinforcement learning fine-tuning. And the task that it solves is this very long task of obtaining a diamond pickaxe, which consists of many subtasks. So the first one is, you spawn in a world, you get some logs, then you craft them into planks, and also craft those planks into sticks, and also you make a crafting table out of the planks. Then you place the crafting table, then you can use those sticks and some planks to make a wooden pickaxe. And you need a wooden pickaxe in order to dig for some cobblestone. And once you get some cobblestone, hopefully you still have your crafting table, you haven't lost it anywhere, and you still have some sticks, then you can make a stone pickaxe. with a stone pickaxe deep underground. You can find some iron ore. Then you smelt it. You need to make the furnace as well. You get some iron ingots. Hopefully, you still have a crafting table and some more sticks to make an iron pickaxe. And now, equipped with an iron pickaxe, which VPT gets about 60% of the time, you can try to find some diamonds, and they're very rare underground, and you have to dig a lot, and maybe 15% of the time VPT gets diamonds, and then it can try to make a diamond pickaxe as a final step. And humans take about 20 minutes, at least according to this paper. I would say like a good human doing it properly should probably take like 10 minutes. With average luck, I've had some very lucky runs where it took me 3 minutes, but on average, it's like, again, 8 to 10 minutes that this task takes. So here's one of the big questions. It's like, this task takes, 10 or 20 minutes, depending on the source, but the agent only has 6 seconds of memory. So how does it keep the thread throughout the task, right? Like that's one big question we try to shine some light on in the paper. And I'm gonna just show you a video of the agent acting in the world. This is like how it looks like. You spawn in a fresh, procedurally generated world. You have no items, and you first go and try to find the tree. When you found the tree, you chop it. You see it takes a very long time to punch the tree. And once it gets some logs, 3 logs is enough, but 4 logs just to be safe is nicer. It does all of this crafting very quickly, places the crafting table, makes a wooden pickaxe, destroys the crafting table to take it for later, and then digs straight down as a true Minecraft professional. And then it gets some stone, and it keeps going. So then in our paper, we basically were treating VPT as like a lab rat, trying to understand how it does things. And this is the figure 1 of the paper, and it shows that like we did 2 sorts of things on our test subject, the VPT agent. First, we did inspect it in various ways. So we were like visualizing attention weight patterns, attention outputs. We did some feature visualization, some salience maps, things like of that sort, some other things as well. And then we did some interventions where we, as any good mechanistic interpretability paper these days, we were doing attention ablations and see what that does to how the agent behaves. And we were doing some silly input manipulations, putting the agent in weird situations and all sorts of funny things, but some of them I'll show. So let's start with the inspection part. Here's one example. And I hope you're getting good enough frames per second on this. Screen share. So this is one of the dashboards that we made where, I choose the attention head that we want to visualize. And on top here, it's all the attention heads and their activations. And this is what the agent is doing. And then on this one with head 2.2, you see some like vertical lines, and it's, neural data, if you will. And then those lines disappear. Does that mean anything? We don't really know. And then this interesting thing happens here when the agent looks up. This pattern appears, and it's like very distinct. And like when I saw that, I was like, oh wow, that's something interesting. And that's roughly the depth at which we left this. So remember, this was very exploratory work, all of it. So definitely would benefit from more eyeballs and hands on this work and on this data. Then the next sort of visualization that we did, which we find the most promising, and some reviewers as well, it's these attention weight patterns. And I will explain in full detail in the second part of the video, but this is roughly what they look like. And yeah, let me pause maybe at this moment. So here, for example, what it's showing, I'll try to briefly explain. Like along the x-axis, it's the time, the episode going forward. And here, the left frame is the frame being attended to And so in this case, that's the first frame of the episode being attended to, and the right frame shown here is the current frame. So if I move the mouse around, if I go down, the current frame doesn't change, but the frame being attended to changes. And then if we go right, you see this pattern changes here. And this is the same moment of the camera moving up, as you can see in the right frame. And it shows up differently in this visualization. So there, the camera moves up. And what this shows is that instead of looking at the first frame or some other frame, it's just looking at the most recent frame while it's looking up. And again, is that interesting? What does that mean? We don't really know. I'll show in the second part of the talk some things that came out of this. There's this other visualization, which I found pretty cool, and it sort of helps build an intuition of how the model might be making its decisions. So, okay, let me try to explain what this shows. So this has 4 layers of attention heads and 16 attention heads in each layer. And if I move a bit forward, perhaps to here, and each frame shows which past frame does this attention head look the most at? So which has the highest attention being paid to it? So for example, in this frame, I think this is layer 0, attention head 9. It's looking at the most recent frame. It's moved to the tree. And on these other ones, those attention heads are still looking at the first frame of the episode. And the brightness says, like, if it's 99% of attention on just a single frame, then it's going to be very bright. But if the maximum is like 5%, it's still the maximum, but it's like much more spread out. So the attention head doesn't really pay too much attention to anything, then it's going to show up as very dark. And I'm just going to roll the video. Let's see what that looks like. And I will pause in some moments maybe. Let's see when it starts crafting. There it opened the inventory. And it's crafting things. Too slow. Let's stop here, for example. So here you can see in this frame, it's looking at the most recent frame. In this frame, it's like a frame a bit before that. And in some other frames, it's looking at the inventory. It's paying the most attention to the inventory. So this is sort of like a little bit of evidence of, okay, maybe it's looking at some like key frames in the past and deciding how to act based on those key frames, and deciding like which part of the episode it's currently doing. So these were the visualizations and examples of those. And this is the sort of interventions part. Let's just run it and pause at second 6. So you can view this as like a massive automated lesion study, in biological terms. And what this shows here is, first of all, on the left, there's the episode. The first plot here is just showing the attack probability at each time step. And then if we move to these squares, you see some green squares, some red squares, and many, many black squares. So what I do here is I take the layer 0, the first attention head, layer 0, attention head 0, and then it has 128 outputs, which I call here neurons, but they should be called outputs, really, for various reasons. Let's call them outputs. And it's an activation, right? Like that single tiny piece of activation, and it's just some number. And what I do is just I zero it out. I say like, okay, I knock out this output or neuron. What happens to the attack probability? And if it's black, that means attack probability is not changed. But if it's green, like this one, it means that, okay, layer 0, attention head 9, neuron 75 or something, if you knock that one out, attack probability goes up by 2%. And if it's red, maybe it goes down by 2%. And I do that for every single neuron, for every single frame, and all attention heads for this episode. So if I run it for longer, you see it lights up sometimes. It's pretty cool to watch. And then notice that while it's punching the villager, the attack probability is like 80% or something, you know, sometimes lower, sometimes higher. So it's like, it's looking at the villagers like, your face looks disagreeable, but I'm not sure, like, should I punch you? Should I not punch you? Here is a punch, right? Like, that's what it's probably thinking. And then notice what happens here. It locks onto this log and is like, oh, that looks much better. That looks much more punchable. And it's like really, really, really certain that it should be punching this log. It stops moving. The attack probability is like 99.997%. So it's like, this looks good. Like, I know what I'm doing. This is great. I'm going to punch this log. And notice what happens with these parts. They're just black. Basically, nothing is happening, which means that, and on the second plot as well, here it shows like that the ablation impact is 0. Maximum possible ablation impact is like 0.0002, which means that if the agent is very certain of its actions with these simple ablations, like tickling its neurons or outputs a little bit, we can't do anything. And this doesn't even help if we go to the log scale, because, you know, activations are after softmax, whatever. Like, it's not a log scale issue. It's just like we can't impact the agent's behavior with these like very tiny ablations. So that was pretty cool. And, you know, the plots are nice. And then we did some very, very silly stuff. So this next video, you know, the first thing the agent has to do is, you know, chop some logs. And I thought, how about I just give you some logs at the start? I gave it 4 logs with creative commands. So like, here you go, 4 logs. Let's see what you do, right? Just for shits and giggles. And this was the first time I did this. What the agent did was it opened the inventory and it just dropped the logs and then went on to find the tree. Like, my jaw dropped there. I was like, well, that's one way to get back in distribution. You know, I got out of this out of distribution situation. But then I tried to like, I wasn't recording a video then I tried to reproduce it for a video, and I couldn't. Like, it took me like 50 runs to have it happen again. So this is very, very rare. Like, it's not, you know, say sentient, whatever. It just happened by chance, but it was funny nonetheless. Then the next part here, you know, the agent has a short-term memory of 6 seconds. And I was wondering, like, what would happen if I just knock out that short-term memory? Like, it just can look at the most recent frame. Like, how well could it do? And it's not doing very well, I'd say. And it sort of basically barely just manages to chop this tree. Eventually, there we go, some logs. Okay, let's open that inventory. And here it looks like, you know, it has some like neurological damage or something. Like, it really struggles controlling that mouse. And when I was doing these experiments like half a year ago, I was reading books by Oliver Sacks, this neurologist with many amazing books. I really recommend him if you're into, you know, brain things. And one of the human cases, one of the patients he described was this British musicologist and composer, a very famous one, whose name is Clive Waring. And Clive, when he was in his 40s, I believe, he had an infection which got into his brain and made him develop one of the worst cases of amnesia that we know of. So his amnesia is so severe that he has like a 7-second, you know, working memory. He doesn't, like, he keeps like waking up from coma like every 10 seconds or something. It's crazy. And if you look at his diaries, they're like completely something else. Like, they're terrifying. And he, like 11:03 a.m., this one broke my heart a bit. First thought, I love darling Deborah for eternity. And then all the other times are like, now I am perfectly awake for the first time. And then 20 minutes pass and he writes the same again and crosses out the ones before, and his diaries are pages and pages of this. So his memory is like really gone. He lives like in the void. But with that, with 6 seconds of memory, Clive can still play long pieces on the piano, which is pretty crazy. And, you know, you can think of VPT as a bit of something like that. Very short memory solves very long tasks somehow. So with that, that's the end of part 1. Read the paper if you're interested. There are links to videos and all sorts of things. Any questions before I move on to the second part? Okay, Max?
Yeah, hey.
Yeah,
Thanks a lot for the talk. Super cool. It's been really fun I feel like I'm learning a lot. So when we talk about these attention sinks, do we have more intuition about how what does it mean for a lot of magnitude of attention to be focused on one frame or one I guess one frame for okay, you're hitting the villager and you're have a lot of attention sort of at this different area, but what can we interpolate beyond seeing that, okay, this frame it's important, quote, quote, for making the next action? How should I be thinking about that?
Good question. And, the question that I'm trying to answer and trying to figure out myself. And honestly, I don't know yet. I will have some sort of hints towards the end of a part 2 where I noticed some, weird patterns, some outliers in the attention, and the behavior afterwards changes in some ways. But you have to remember, as you mentioned, that it's attention to the whole frame. We're not even looking at which part of the frame it's looking at, right? We tried some saliency maps for that, but it didn't really work. So, it could be many, many things in the frame. And I tried some sort of silly experiments of blacking out some parts or changing the frames, but basically I don't know yet. And I don't think we know as a humanity how these sort of CNN plus transformer agents make their decisions yet. And I think it's a very interesting question to figure out.
Cool, thank you.
Any other questions? All right, let's move on. Let's see if we can fit this part. So part 2, this is going to be a free blue one brown style video. Hopefully everyone knows who that is. I'll do a bit of a plug in a minute. And again, this is the first public reveal of this video. I haven't shown it publicly anywhere. Yeah, so first, some motivation, why did I decide to do a video of this thing? Basically, I was in our weekly meeting with my collaborators on this paper, and I was trying to explain some recent work I did. I was flailing my arms wildly. I was look, if you take this attention pattern and then you put it this way, and then I draw it, and they were looking at me wait, so are you saying it's this? And I'm no, wait, and in my mind, I was shit, if I only had a good way to visualize these parts moving, it would be great. And I always wanted to learn to make these videos free blue one brown, these explainer videos. And I thought okay, this is a good moment, let me try to do it. And then a bit of motivation about why focus on the attention weight patterns. It's when I saw them, I was ooh, this looks very promising. Some other people in the mech-interc space saw them, and they saw the similarities to something that happens with LLMs. With LLMs, some people have figured out stuff, induction heads were found through attention patterns, and there are similarities, so it looks very interesting, and some reviewers suggested the same. So we were first part of the work was exploratory. We explored, and we think, this is the part that's worth digging deeper into, these attention weight patterns. So, oh yeah, I promised the plug of Free Blue one Brown. It's a YouTube channel by Grant Sanderson. He has 7 million subscribers. And just a single thing, if you have a video on Fourier series that has 18 million views, you're doing something right. His videos are amazing. My personal favorites are probably the Cosmic Distance Ladder that he did with Terence Tao, 2 videos. Really recommend them. Okay, so now let me switch to this thing. There we go. Where is the second part of this? Okay. So let's go. So this is a bit of an explainer of VPT again in more depth. So we have a standard reinforcement learning loop with pixel observations, the agent that takes those observations, and then keyboard and mouse actions that get fed back to the environment and producing the next observation. You know how these things work. Now let's take a few actions here. So mouse movement, I show with this arrow, pulling on the mouse. The agent has to control the mouse. And you can have multiple keyboard actions at once, like here, forward jump sprint. And again, forward jump sprint. Now, let's take a few more time steps. And you see it's like this runs at 40 times slower than real time. And it's a really like a low-level control task or problem that it's solving, right? At 20 frames per second, it has to keep producing these actions. And from here, we're going to speed up to real time for a bit now. And it's like really a lot of actions, as you can see. And it's the same video I showed to you before. And here you see the left mouse button pressed as it chops the tree. And as I mentioned before, the task is to obtain a diamond, which requires many higher level steps, such as chopping this tree, crafting a wooden pickaxe, etc., etc., etc. So let's wait for it to stop chopping that log. And there, notice now it pressed inventory. So we're going to watch it navigate the inventory a bit slower. And notice that it has to use those same mouse actions that it uses for camera. It has to use them to navigate the inventory as well. This is an agent view, like how the agent sees it after downsampling. And you see it's crafting the logs, navigating the crafting menu there. And, making the wooden pickaxe. And now let's zoom in on the agent itself, VPT. So it has two parts, a convolutional neural network and a transformer. And we're going to focus just on the transformer bit. And the transformer part has these parts called attention heads. And we have 4 layers of them and 16 heads in each layer. And we're going to zoom in on just one of them, attention head 0.9. So layer 0, head 9. I will call them 0.9 and such from now on. And just one part of this attention head calculation is the attention weights. And these are like not the network weights. They change at each time step. They're more like activation parts. And they show how much attention is being paid to each of the last 128 frames. So it's just an array of 128 numbers. And yeah, the agent has 6 seconds of memory. Remember, 20 frames per second, 128 frames, 128 over 20 is 6.4. Now let's look at this one number at the end here. It's 0.87. It shows what % of attention is being paid to this one frame. And in this case, it's 87%. Now, let's slowly take a few time steps. And the numbers is always very high, like 92%, 91%. And that means that this attention head 0.9, at least in these frames, always looks at the previous frame. Now, let's switch to another head for now. And that's going to be head 1.10. And this is what the attention weights look like for head 1.10. And here you can see that they're much more spread out. And like there is no single large number. They're just like 7%, 2% all over the place. Let's take a few time steps again. And that, things are moving, but the numbers don't really change. Like there is no big numbers. It's just like spread out attention all over the place. And the numbers stay spread out at least until after time step 547. You'll hear that number a lot, 547. And we'll make a pause at frame 547 again. Here. So I don't know if people are old enough to know this meme. from CSI, crime scene investigation. See if you can enhance that license plate. And it's like zoom in, zoom in, zoom in, zoom in, zoom in, and then enhance, and you see the license plate numbers nice and crisp. Yeah, hopefully everyone got the time to see it. Let's move on. And let's look at that top left frame here again, and this part in particular, and we're going to enhance. There we go, nice and crisp. This is just the image before being downsampled to the agent. So that's the secret, how we achieved it, right? And notice the action. That's left mouse button and sneak, which is basically shift click. And if you've played Minecraft, you know that this will move the item here, the wooden pickaxe, to the toolbar. Shift click, right? That's how you control the inventory. And we will get there. But first, let's make a note of this part of the image, and let's put it here for now. And we'll note down the number, the frame number, 547. So we remember what it's about. And okay, now let's craft that wooden pickaxe. Let's look at the wooden pickaxe again, and boom. And let's try this functionality. Yeah, okay, that works. There, we're crafting the wooden pickaxe. Shift click, wooden pickaxe in the toolbar. Okay, let's remove enhancing, and let's focus on this number at the end of the attention weights. This guy. And this number represents the amount of attention that head of 1.10 pays to frame 547, the frame where it crafted the wooden pickaxe. And I'm going to move a few frames ahead now. And the number gets pretty large, like here, 20%, but it's nothing to, but nothing to write home about. And as it reaches, the end of this line, notice it just pressed the inventory key, which will close the menu. And look at what happens to the attention paid to frame 547. Now suddenly it's large numbers. It's trying to remember that frame. It crafted a wooden pickaxe, 70%, 49%. And this actually continues for the full context length. It's like really, this attention head really keeps a look on this particular frame and this moment in time. So let's focus on just these 128 numbers. We got rid of a clutter. Let's move them a bit. Let's put the numbers into a single line for clarity. As I mentioned, it's just a single array of numbers, right? And now we need to fit all of them on the screen. So let's make them vertical. That's good. Now let's try to get rid of that annoying dot, dot, dot. So it's 128 numbers for real. That doesn't fit. Let's make them smaller. And let's zoom in on this little guy. And there we go. Okay, I think we can work with that. Let's add a heat map towards the left, indicating how large the numbers are. Okay, that's the heat map, and it's just a single number being large, and maybe here is another number at 9% here, perhaps. Okay, not bad. Now, let's go to the next frame from here. And before we do that, let's get the observation frame back. Okay, that works. Okay, let's move a few frames ahead. So it starts drawing this pattern, that you saw in the first part of the presentation. And now you hopefully understand what it roughly means. And let's speed it up a little. There we go. And so to reiterate, a diagonal line like this will show attention being paid to a single passed frame. And we can see another dimmer line forming above here, and that's the frame right before opening the crafting table. Let's just focus on that pattern now. And we're going to make it a bit smaller, and we'll add the time steps before and after. There we go. And we'll need some axes here. So hopefully it's clear what this shows. The memory index, the time step, part of the episode, and a single bright line like that is, like a single keyframe being looked at like that wooden pickaxe crafting moment. Any questions here before we move on? Just speak out. I've hidden my Google Meet. Okay. If not, we're going to take... This is the part I was really struggling to explain to my collaborator, so let's see if this works here. We're going to take that single diagonal line and make it horizontal now. And we're going to turn it into a bar chart, add some axes, and draw a line over the tops of the bars. And then we'll say, bye-bye bars. Okay, so to recap, this is how much attention at 1.10 pays to frame 547 during the 128 frames after it makes that wooden pickaxe, after that frame. So from here to here, turned into a line. Hopefully this is clear. And this is where this part of the talk will get to like really, I don't even know what to call it, like really research code style. Because we're going to move back to the slides. Where are they? There. And this next part, like I haven't finished, and it might be that the video continues with this next part. It might be that we find something different, and we'll make the second the other part of the video different as well. So we had this plot, right? This is the same plot as here, and there, same plot, right? And now we're delving into that research code territory with plots like this. This is just like copy paste from matplotlib, and the axes are like value and index, like very, very descriptive. I know, but hopefully you believe me that this is the same plot, right? Like the same attention being paid to that frame. And so this line represents one episode, but I've run VPT for many, many episodes, and I have a lot of them, and I do keep logs, and I know what items it has at each frame, so I can detect the wooden pickaxe going from 0 to 1, the count of wooden pickaxes that it has. Here it's frame 547, goes from 0 to 1, so I can make an automatic detector of this moment. So I did that, and I plotted like 70 episodes or something, and this beautiful beast came out. I know, this is like really polished plots. Excuse me for that. So I looked at this plot and I'm like, okay, but maybe that's interesting. The attention being paid is like 50% on average. Maybe there are some patterns, but then I noticed these two plots, these two lines at the bottom, like this green and red one. I was like, what is happening there? So basically, the agent gets a wooden pickaxe, but the attention head doesn't light up. It lights up in 68 out of the 70 episodes, and in these two episodes, it just doesn't care. It's like, whatever, wooden pickaxe, wooden schmickaxe, don't care. So I, went and investigated this, and this is another screenshot from my research workflow. And this is 3 episodes, and the top one is like a regular episode, and this is the 5 frames up to that moment of crafting a wooden pickaxe, or getting a wooden pickaxe, perhaps, is a better way to say it. And so in this one, it's like 11% attention on average, and these two, the middle one and the bottom one, are the 0 lines of attention. And the bottom one is actually not very interesting. I mean, it's funny, but what happens is basically the agent makes a wooden pickaxe, and then it's like, okay, I'm gonna mine things, and whoops, I dropped it. There is a drop key, and it presses the drop key, and it drops the wooden pickaxe. So now it has 0 pickaxes, and then it picks it up again, and my detection mechanism, says, oh, wooden pickaxe, and draws that line. So that's just, a false detection, basically. And it's not that interesting. And the agent actually recovers and, acts properly as it should. It digs down, finds stone, and all of that stuff. Now, this middle episode is more interesting because the agent does craft a wooden pickaxe, but it doesn't pay any attention to it. And it didn't have a wooden pickaxe before, so, what's happening there? So I was like, like I immediately saw it, like what's different in that episode, but I'm going to zoom in on this frame and a frame from a regular episode. So on this slide here, like you can try and see the difference. And if anyone's a Minecraft player, like you'll notice that it has much less items here in the crafting menu, and that's because it pressed this green button here. And I'm gonna skip this video, but I'm gonna show this one. Wait. Okay. Actually, yeah, whatever. Let me show you a regular episode. I would just go to the exact moment where it happens. There. Let's see, how do I control this? Too fast. Shift. There we go. Let's go back. Boom, 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 boom. It crafts a wooden pickaxe here. And you see this little button here shows a red X. So it's not pressed. And I'm gonna, so this is a regular episode. It crafts a wooden pickaxe, everything is fine. And the next thing it does, it takes the crafting table and it looks down and it starts digging. And this is a very, very, very reliable behavior. As soon as the agent gets a wooden pickaxe, it destroys the crafting table and it looks down and it digs, like every single time. So now let's move to that episode with no attention being paid to the moment of crafting the wooden pickaxe. And let's just watch it. It's a pretty regular episode. Like, this happens quite often. It has to dig through some leaves. It digs the logs. It will happily craft them. Everything is happening as usual. Make that crafting table, make some sticks. There, let's see. Oh, there we go. So what happened here? Frame by frame, let's go. Boom. Boom. So here, showing all recipes, and the agent goes there and clicks this button. I don't know if it's an accident. It rarely happens at this time of the episode. Like, it happens more often later on when making stone pickaxes and stuff. But here it presses this button. And now it sort of goes out of distribution, I think. But it still manages to craft the wooden pickaxe. It's like, it's in a different place than usual, but it makes the wooden pickaxe. Let me just resume and pause. And it destroys the crafting table just as usual. And here you would expect the agent to look down and dig. That's the usual behavior. But remember, attention head didn't notice the wooden pickaxe being crafted here. The attention head 1.10. And what the agent does instead is it goes looking for trees. And it's also like a bit confused. It's like, maybe I should dig down, but this tree looks disagreeable. I don't know. Maybe I'll just dig some dirt. That looks nice. I look down. Nah, actually, I'll look back up. And yeah, so this is like a very small hint of those keyframes being important. And if somehow that keyframe gets missed, like the agent seemingly missed the moment of crafting the wooden pickaxe, like one of the attention heads missed that, it seems, then it couldn't continue the task. And like it went out of distribution, or like it just failed afterwards. So that's pretty interesting. And that's basically that with the progress. And yeah, thank you for your attention. And if you have any questions, shoot them now. If you have any comments, feedback, anything, my contact details are in my website. Thank you.
Nice. Great session.
Thank you.
Thanks for joining. Yeah. Are there any questions?
Yeah, I got a quick question. So, like, let's say you have some strategy that you wanted to, like, you have a predefined strategy that you already understand. Is there a way that you could sort of use this attention map and sort of these different ways of looking at the patterns within the network to kind of maybe group your strategies or something like that. You know, in Minecraft, to craft a diamond pickaxe, it seems like there's basically just one route. You don't technically need to go get the iron pickaxe or the wooden pickaxe. I think you can just go find the ore. I don't know if that's true, actually. I haven't played Minecraft in maybe 15 years.
I'll give some comments on that part, but let's also, I'll let you finish that question.
Yeah, anyway, my point is, like, let's say you know that there's a couple different strategies to getting a diamond pickaxe. Either one, you go kill the whatever to get a better sword, and then, or the other one is you just go find all the materials. How would you sort of know, using your sort of understanding of these strategies and saying, okay, here's one strategy, here's another, how would you sort of look at these attention maps in these different areas? Would the idea be like collect a bunch of examples of one and the other, and then like compare how they're different? Or would it be just like letting it go unsupervised? I don't know. Like, how would you think about that kind of thing?
So first, I'll give some Minecraft comments. Like if you look at speedruns, when I mentioned I got lucky and I got a diamond in 3 minutes. Yeah. That's going through the full tech tree. You know, get a wood pickaxe, stone pickaxe, iron pickaxe, find a diamond, dig a diamond. You know, like if you're very lucky and very fast, it's 3 minutes, and I've seen VPT do it in 3.5 minutes or so as well when it's lucky. That's one strategy, and that's the strategy that VPT follows. But there are others. If you look at speedrun.com, there are like genuine random seed ways of getting a diamond in 10 seconds. And what you do is basically you have to get very lucky and spawn right next to a very deep cave. You fall and jump into that deep cave, and you find a creeper. And if a creeper explodes diamond ore, you get a diamond. Another way is so that's how some speedruns, that's how the no structures speedruns are done. Sure. Now, if you add structures, which VPT has access to, you can go find a village and raid the chests, and there are sometimes diamonds there, I think, I believe. And that's another way, and that's the 0.5 second speedruns, where you just spawn in a house, open a chest, and get a diamond. Half a second, you've got a diamond, but that's pretty boring. But in terms of like VPT, the only thing that it does is this, normal, regular route through which to achieve the diamond. And now, so there is no classification of strategies because there's only one strategy. But what I would really want to do and figure out somehow through some, I don't know, either unsupervised, probably supervised way, but basically, when we have these subtasks, right? So it seems like VPT acts very, very different in each one. Like when it's, up to getting wood and pickaxe, it really knows what it's doing. And there seem to be some sort of shifts in the attention patterns between those moments, between getting a wooden pickaxe, getting cobblestone, getting a stone pickaxe. So what I would like to do, it's in my big to-do list, is make some classifier based on the activations of a network to figure out which part of the task, of this 12 or whatever step task, the agent thinks it's currently in. And it's like visually pretty easy to, see if it's running around and chopping trees, it's in the first one. If it's, digging down, it's probably somewhere here. And then what happens as well, like when it gets an iron pickaxe, it actually quite reliably looks back up and starts digging forward, like in these like shafts, instead of digging down to look for diamonds. So that's another like distinct thing that can be easily detected. Like which part the agent is in. Can we build a classifier to classify that based on activations? And then I would take that classifier and apply it to that moment where it crafted the wooden pickaxe but didn't notice it, and see. Ask the agent, like, okay, what do you think you're doing now? And I would expect it to say, like, oh, maybe I'm chopping logs, or maybe I'm digging down. I don't know. Like, that's the dream. That's one of the avenues. Maybe I shouldn't be revealing this publicly. I'll get scooped. I don't mind. Please do this work for me, or come join me. I'm very happy to see this move forward, whether by me or by others.
Okay, that makes a lot of sense. Basically,
Cool.
I think I just described making a classifier. You just say, okay, here's a bunch of sections of log, here's a bunch of sections of planks, here's a bunch of sections of iron ore or whatever. And then based on these either attention maps or just the internal representations of the network, put another head on it and say, hey, predict which of the, I don't know how many there are, 12 sections of this path. Try to predict which of these you're in. And then is it possible is, I guess, really just the thing that we're looking at right now. And then there's another level of like, what do you do with that is interesting and curious, but I'm not, most of them we're just saying like, is it possible to sort of differentiate them?
Yep, exactly.
Cool. Thanks.
All right. If we don't have any questions, we can thank our speaker. Right.
Thank you for having me.
Thank you for joining us. Yeah, thank you. It was great.
Yeah, I had a really good time. Thank you so much. I feel like I learned a lot.
Happy to hear. Thank you very much.
Thank you. All right. If we have, if you guys have any questions, you can actually drop him a mail. I hope he's okay to reach out.
Yeah, definitely.
We'll answer the questions offline. All right. Thanks. Thanks, Karolis. It was fun.
Thank you, Rahul. Yeah. Bye-bye.
Bye-bye.